Good day everyone. Today let us see in Maxima and Minima one inscribed model sum. We are considering now a rectangle inscribed in an ellipse. Find the area of the greatest rectangle that can be inscribed in an ellipse x squared by a square plus y squared by b squared is equal to 1. This is called the standard equation of the ellipse. Okay. So here a and b are constants. Then you want to find the area of the greatest rectangle. That means you want to maximize the area of the rectangle. So that is what you understand from the figure. Now this is an ellipse. Here the ellipse will be symmetrical about both the x-axis as well as y-axis. The PQRS is the rectangle that is inscribed in the ellipse. You can inscribe many rectangles in the ellipse if you change the positions of that PQRS for different values of theta. Actually you will be getting different ellipses. Now we have got one ellipse. Here this P, that point, I am writing as a general point on the ellipse a cos theta b sin theta, because that point a cos theta b sin theta will satisfy the equation of the ellipse for all values of theta. When you put x is equal to a cos theta, x squared by a squared will become a squared cos squared theta by a squared. A squared and a squared will get cut, you will get cos squared theta. If you put y is equal to b sin theta, y squared by b squared will become b squared sin squared theta by b squared. B squared and b squared will get cut, you will get sin squared theta. You know cos squared theta plus sin squared theta is 1 for all values of theta. So this is called a general point on the ellipse. This is the first quadrant. So both the x coordinate and the y coordinate are positive. When you come to the point Q, the x coordinate, the x axis is on the negative side, no? So the x coordinate is negative and the y coordinate is positive. Or the x is also negative, y is also negative. So both they have marked negative. Coming to the point S, x is positive and y will be negative. So this is a cos theta minus b sin theta. So first you should understand the coordinates of the rectangle, all the four vertices of the rectangle. Then the next thing is, here you can call this PQ is the length of the rectangle, PQ or SR. Now that PQ is nothing but PF plus FQ. Now PF will be equal to QF because of the symmetry. Now when you say the point P is a cos theta b sin theta, what you mean is this OE, that is a cos theta, and this PE, that is b sin theta. When OE is a cos theta, FP is also a cos theta. So now this is a cos theta, this side also will be a cos theta. So you will be getting the length as 2a cos theta. When you talk about length, you should not consider the negative of the coordinate, because when you talk about a point, the coordinate, then whether it is positive or negative, that depends upon the quadrant. But when you talk about the length, you should only consider the absolute value, only that one. So 2a cos theta. Similarly, the breadth will be PE, and PE will be equal to ES, PE plus ES. PS is the breadth. So PE is b sin theta. Here another b sin theta. So the breadth will be 2b sin theta. So you have to first remember these facts before going into the sum now. So now here a and b are constants. So now only the capital A, which is area. So I am straight away going to the thing given. So here given, what is given now? An ellipse. What is the equation of the ellipse? It is x squared by a square plus y squared by b squared is equal to 1 is given to you. So that gives you an idea that the A and B are constants, because the ellipse is given A and B are constants. That you should remember while differentiating. Then the rectangle PQRS is a rectangle inscribed in the ellipse. Okay, it is the rectangle inscribed in the ellipse. So these are the things given to you. Now here you need not actually prove anything. You are going to find the area. So I am writing the side heading as to find. I want to find the area of the greatest rectangle. That means I am going to maximize the area, right? So to find the area of the greatest rectangle. So now we can move on to the proof part here. So coming to the proof. Now, what is the length of the rectangle? The length of the rectangle, that we will represent by the letter small l. Okay, normally length is L and breadth is B. That will be equal to 2a cos theta, which I already explained to you how it is. Then the breadth of the rectangle, that we will represent by the letter small b. That will be equal to 2b sin theta. Now, area, that is equal to capital A, that will be length into breadth, which is 2a cos theta into 2b sin theta. Okay, so now you write one 2ab, that is one 2a and this b. So you are left with 2 sin theta cos theta, which you know that is sin 2 theta. So now I am getting a is equal to 2ab sin theta. So now you know when a is equal to 2ab sin 2 theta, the a and b are constants. So now theta is the only variable. So what are the two conditions for us for a to be maximum? For a to be maximum, okay, for a to be maximum, you know the two conditions are dA by d theta, that will be 0, and then d square a by d theta square will be lesser than 0. These are the two conditions we have to consider for making it the area greatest. Okay. A is 2ab sin 2 theta. Let us now find dA by d theta. That is equal to, write the 2ab as it is. For sin 2 theta, if you differentiate, you will get 2 cos 2 theta. You can write it as 4ab cos 2 theta. Coming to the next derivative, d square a by d theta square, that will be, write the 4ab as it is. If you differentiate cos 2 theta, you will get minus 2 sin 2 theta. So you will be getting minus 8ab sin 2 theta. So I have found the two derivatives, dA by d theta and d square a by d theta square. Now let us move on to the first condition. We will equate the first derivative, dA by d theta, that is 4ab cos 2 theta, that is equal to 0. Now you know a cannot be 0, b cannot be 0, 4 cannot be 0. So what does it imply? It implies cos 2 theta is equal to 0, that you can write as cos pi by 2. So when cos 2 theta is cos pi by 2, 2 theta will be pi by 2 and theta will be pi by 4. So I have found that theta is pi by 4. Let me check whether for this value of theta the area is maximum. So I will come to the second derivative. In the second derivative, I am going to substitute theta is equal to pi by 4. So I will be getting minus 8ab into sine 2 into pi by 4, right? So I will be getting sine pi by 2, which is 1. So I will be getting minus 8ab. A is positive, B is positive, 8 is positive. There is a negation here. So it is lesser than 0. So now you got a theta for which the second derivative is negative. So now I know the area is maximum. So I can conclude that it is the greatest one. Okay. Now let me find what is the greatest area. That is what I have to find. The area is 2ab sin 2 theta. So it is 2ab into sin 2 theta is 2 into pi by 4. So I will get sin pi by 2, which is 1. So I will be getting 2ab square units. So now you can write the conclusion as the area of the greatest rectangle that can be inscribed is 2ab square units. Hope you understand this sum. Thanks for watching the video. You can actually subscribe, and then if you have any doubts or if you want any more explanations, please write them in the comment section. Okay.